Okay. Well, I'm tempted to say good morning, but people are everywhere in the around the world right now. So good morning, good evening, good night, I guess too. And welcome to LAS 2020. Woo! Now, if you are here with me, you would hear clapping. But this is also the first occasion that we have an LAS online with all of us at home because it's 2020 and it's the kind of things we do nowadays. Um, but I think that we'll all be happy with what we have prepared. We have a very nice program with a lot of talks, with breakout and buff sessions for everyone who is interested in Linux and well, free software operating systems. Now you will see that all our talks will be recorded. Uh, we will upload some videos in the future. They will be on YouTube as well. You will see a couple of social events, so that since we don't have a hallway or a place to have a coffee together, we can still hang out and do stuff. You will see the Amalfico store as well as pub quiz. We have a hashtag called hash LAS 2020. Tweet toot about anything you like, and well, remember to tell the world about the things we're doing and the things we're saying. We'll have two keynotes from Melissa Logan and Greg Harna. I think that they're both interesting people coming from our communities, but also from spaces that are with, well, very high responsibility. And I would very much recommend you to look into that, as well as the panel that we're going to have on Saturday. Very quick reminder of our sponsors, Canonical, Collabora, Red Hat, Elementary, and CodeThing. Thank you very much for supporting LAS. Without you, this would be impossible to have. And well, last but not least, we have a code of conduct. Remember that we're all people here, and well, stay civil and stay friends. It's very important. And without further ado, well, I hope you all enjoy LAS. Let's start with the first presentation. Thank you, and welcome to LAS.
Thank you very much. Hello all. Welcome to LAS 2020. Can somebody just give me a confirmation that I am audible? Thanks. So let's begin. I am Umang. I am a generalist open source software developer for a couple of years now. Recently, I am working on a project called Lip Camera. I don't think I have camera right now. That's ironic. Yeah, I don't have a webcam right now. Sorry, it's. I thought it could go with presentation and audio only. Yeah, so is that okay? I guess so. Okay, sure. Thanks. So let's begin. So let's talk about the like video capture Linux media domain for a while. What happens is like a while ago, like 10 to 15 years ago, the Linux media and the video capture domain was quite simple. You would have a camera sensor at the top, and there would be an interface, CSI2 or even parallel, and that would get exposed through a video node. So writing applications, user space applications, was pretty easy. You would have only one place for control, one place to look for frames, and just display it to your output window. So this was basically very simple, and it worked well for a while, but then things get complicated. Yeah, so complexity increased with image signal processors being introduced. So let's talk a bit brief about what are ISPs, or image signal processors. They are system peripherals. That means they are operating at very high frequency that operate on a digital images. So basically, the raw data captured by the sensor is then pushed down to ISPs, and they do some stuff that we are going to talk. So basically, DMA, resizing, scaling, cropping, or pixel format conversion are some of the things that they would do. These are the basic ones that basically were found in many, but there are other ISPs. So ISPs is basically a group of building blocks that have some specific operations on the raw data that's been captured. So imagine a pipeline, or simply a GStreamer pipeline. You would have elements and the data would flow through them. So image signal processors were then, but they are basically system peripherals. So they were like embedded on the SoC itself. So in order to manage the data flow through these peripherals, kernel exposed a new API named Media Controller. Before that, to capture like the video frames and all, there was already an API called V4L, Video for Linux, and V4L2. So that part was sorted, but the introduction of ISPs led to a need to introduce a new API called Media Controller in the kernel. So looking at a high level, what exactly has happened? I cannot see my slide. Okay, so yeah, the hardware topology got complicated, like you can see here. You would have some sensors. The red boxes are the sensors, like two sensors and a flash maybe. The ISP's building blocks are denoted in green. So you would have some subdevs, something resizer, and the blue boxes are the API. So mind you, these are the video nodes. They are also configured. They are also interfaced with an API, maybe V4L, and the ISPs were controlled using something we discussed as Media Controller. So two different APIs to manage the video capture here. Okay, so looking at very high level, for a camera application, earlier it was just V4L2, one place to look for frames, one place to control them. And now with the introduction of complex ISPs, you would have V4L2, you would, the camera application would also need to know about media controller, like how media will flow through the peripherals, subdev. So it became a very complex task to write a camera application without the knowledge of like hardware complexity you are handling. And being very tied to a hardware is something which does not scale in the long run. So this went for a while in embedded, and like you have seen, like the mobiles and the cell phones had cameras which are which use basically this this framework, or like practice, more or less to say. But since last couple of years, those cameras are slowly coming to the personal computing world, the laptops, and few other like UVC devices and all. So we need to address a problem here. We need something which can abstract all this complexity and let application developers write application in such a way that they are portable, they run, basically depict the main business logic of the application, and being able to run on different and not care about the platform on there which are running. So this is the problem statement as of now. Applications are requested to know a lot of details of underlying hardware, and capturing frames, meaning like you have to really know about what peripherals you have on the hardware and configuring it before the application can even use it. And yeah, the media graph that I showed you earlier is from like 10 years back. So it was already complex 10 years back, and modern laptops that are shipping with powerful ISPs like Intel IPO3, I rather not show the media graph here because it's very complex and I just don't want to. You can look it up online, maybe, and let us know. And the details would be worried about the lip camera developers. So yeah, this is a reply on a mailing list. Web camera not recognized by Dell Latitude, this specific model, because it was shipped with an IPO3 camera. The reply was, laptops, I will just read it out, embeds one of these new complex cameras from Intel. They require IPO3 driver. Though unlike traditional webcam, you need special user space to use it. There is no embedded firmware to manage focus, white balance, etc. User space code need to read the stats and manage that. As of now, there is no good plan on how to support this as your user space. So I hope you have pretty much understood what is the problem we are dealing with here. So yeah, that was the motivation or the background for which the lip camera has been started. It is being actively developed by Linux Media folks, and yeah, some other consulting firms as well, very specific to related to the needs. So let's get into that. Lip camera is a complete user space camera stack. It abstracts away all the complexities as we discussed about V4L2, media controller, hardware topology, everything. It aims to be compatible with already written media applications, V4L2 based application, and aims to like provide a layer so that we can it can be used on Android and Chrome OS. Already we had a good amount of documentation. We have application developer and pipeline handle that we will discuss, and a couple of sample applications that we use for testing and basic dog fooding. So you can just try them out and see for yourself. Now let's, okay, we are mail-based development. I know mailing list plus patchwork. Basically, I think that's the workflow the Linux media domain were comfortable, so they started with that. We use Meson and Ninja, and it's quite like, it might sound complex, but as of this talk goes, you will find it's not a very like, I come from a background where I haven't done much Linux development. Mostly I was working in user space, but the community and people are very friendly, very newcomers friendly. So I think if you plan to contribute, please check it out. Let's talk about complex cameras debate. There are a couple of, if you want to get more into the problem space, specifically the problem space, why embedded cameras are difficult and like complex cameras on Linux, these are the 3 talks I would recommend. You can check them out simply searching for them on the YouTube. They are a personal favorite of mine and basically help this talk that I'm delivering right now. Okay. Okay. So here is the entire camera stack, a bird's eye view. So you can see the kernel space already has like a media device, video device, and V42 subdev. The lib camera will interact and abstract all of this for applications. We would have we have a V4L2 compatibility layer, so existing application can work on it. We also have GStreamer element that it can use. We, as of now, don't have language bindings, but there is, I think, a discussion going on, and we would start with Python. So basically, just to mention, libcamera is being developed in C++. So I think for now, C++ would be a strong association if there is any application wants to use it. But yeah, shortly you should look out. There is a plan already planned for language bindings, and we also have a Android camera hardware abstraction layer, which is which sort of decently works on the Chromium OS as well. So this is the bird's eye view for libcamera. And now I think we will go into libcamera architecture. So at the top is the public API, which the applications will interact. At the core, libcamera has a device manager, which will start and enumerate. It will find all the camera video capture devices attached to your systems and expose camera device objects that you can use. We have state machines, so basically to track what is the status of the camera. It's running, it's stopped, or it's in configured state or something like that. We have streams, what streams are supported by the camera, what role do you want to use for video capture, or you want to use for a still capture. So depending on that, the camera device will give you best suited streams and at which an associated resolution. And you of course have access control so that no two applications simultaneously asks for the camera at the same time. So this part is device agnostic. This has nothing to do with the underlying hardware, and all the device specific stuff goes into a pipeline handler, which will do all the things, video nodes, media controller stuff, and set up pipelines, set up the flow in which the data flow was intended to be, because you have different, like Rockchip would have a different pipeline handler and rather than a Raspberry Pi one. So you will have a Raspberry Pi pipeline handler, and will have a different Rockchip pipeline handler. So all the device specific stuff goes here. And the device manager is smart enough to figure out what the platform is and use the appropriate pipeline handler. And mind you, like pipeline handlers are a bit complex in a way, like camera objects can be different, but they can use the same ISP on the hardware. So no two cameras will gain exclusive use of the pipeline handlers. Another thing is image processing algorithms, which is also very device specific. And this is shown in a blue kind of box, which shows the sandboxing, because image processing algorithms, or 3As as we talk, are very vendor specific, and vendors might need to protect that core IP. So libcamera already has has been developed with that frame in mind. So we are LGPL, lip camera is LGPL, so that we don't tie into some binary blob in the future. So it has been designed in such a way, and you have some helpers and support graph, buffer allocators, pipeline runners, and debugging and logging, which are, I think, if you plan to develop these, will become obvious if you read the documentation. Yeah, so platforms supported by lip camera as of now, we have UVC, like your USB webcams. IPU3 is supported, Rockchip, WIMC, which is a test driver, and we do a lot of testing, like for not if we don't have some hardware or something. And for Raspberry Pi, we also have working with Raspberry Pi folks for the support in lip camera. Lip camera API. So let's talk about something which is the core of this talk. I want to just give an overview how the API and how would application would interact with lip camera. So basically 5 things. We have camera manager, we talked about a little bit, which will do the camera enumeration, which will find all the devices attached to your system. Then we have camera configuration, which will just set up the camera, prepare it for the intended use. We have config validation, like if the application has specific requests, suppose an application wants to capture a specific format or a specific capture at specific resolution, the application can request it through the configuration and it will be sent back to the camera for validation. After that process happens, it's just allocating some buffers for the data being written. And finally, we have the frame capture. So let's try to map it out a bit into the code. Yeah, camera enumeration, camera manager. We make a new camera manager. We start the camera manager, which will like set up pipelines, set up, find all the devices, and make camera objects. And you can retrieve the camera from camera managers with the cameras API. We just iterate over them and we just print an ID. So camera enumeration. Let's talk about camera configuration. After we have got the cameras, we select the first camera we have. So 0 is the first camera, suppose. We get a pointer to it. We acquire a camera. So this is an exclusive lock. Once a camera has been acquired, no other application will be granted access to that camera for the time until it is released. So after the camera has been acquired, it is just we would generate a configuration, and for the configuration we specify a stream role. Stream role is basically what's the intent of the use. So basically you can tell it's a still capture, or it's a raw capture, or it's a video capture, or something else. So accordingly, the camera will generate a configuration and store it in config. Now comes the validation part. So after a configuration has been, camera configuration has been stored, so what it contains is a stream configuration. So stream configuration is nothing but a specific configuration for each stream role. Like you can ask for multiple stream roles or other stream roles. So each will have a specific stream configuration, and you can suppose this is the stream configuration the camera has given you, and default still capture configuration. So this is the default one. So if I print this out, it will tell me it will capture at 1280 720p resolution with the format being MJPEG. And let's say I'm not satisfied with this configuration, so I as an application developer can write, let's see, I will give, I want to capture at width 640 and height 480. So I will just try to amend these two parameters, and again I will try to validate the config. So what happens here is if the camera can provide this resolution, it will just simply validate it. If it doesn't, it will give the nearest configuration. So suppose if this is not supported, then a lower one is supported for suppose 320 into 180. So it will just try to amend this and give you 320 and 180. Or similarly, or if you go higher, it will try to get it. But if it doesn't have, it will just keep it as default. Sorry. After the configuration phase has happened, we will just allocate some buffers. So you can use your own allocator, or libcameras provides one for you. It's a frame buffer allocator. It will iterate over the stream configuration. You can, like, a camera can ask for multiple streams, as we talked about. So basically, I can ask for a stream where I want to look at the camera is just streaming all the frames, but I want, at a click of a button, I want a frame to be saved to a disk. So camera can ask for like something like NB12 and MJPEG. So NB12 will just keep the stream going on in my application window, and when I hit like capture, it will just use the MJPEG stream and capture that frame in MJPEG and save it to the disk. So in a way, like, application can ask multiple from the camera itself. So for each stream, you have to allocate buffers. So we would iterate from the configuration. We would iterate on each stream configuration and allocate buffers. It simply allocates like required number of buffers it thinks it can, but I am sure you can specify your own set of requirements as well for the buffer allocation. Now comes the frame capture part. So after allocating buffers, you can create a request to the camera where request is at least one stream, like one stream from the stream configuration and the frame buffer you have got like from the previous slide. So request is nothing but one stream, one buffer, and you just queue it to the camera. After after the requests are queued to the camera, you just run camera start, and it will start writing data to those buffers. And after how do you know like when the buffer is full? Because you will know when the camera has emitted the request completed signal, and thereafter in the signal handler you can just go and take out the buffers from the request object, and simply you can just do like your frame capture is then complete. Lib camera sample applications, we use a cam utility, which is a Swiss knife. It's a testing tool. It has got all the configuration options. We have QCam, Qt based Q GUI application. We also have simple cam if you just want to read like the minimal reference code as we did just right now. So you can just look at the simple cam and try running it and reading it. It's over commented, so you will have a good grasp on how to write a application with libcamera. There is decent documentation and app developers guide in the tree itself. You can also look into that. So yeah, please join. libcamera is a young project. It started around 2018, maybe. Yeah, I'm not sure, but yeah, somewhere around 2018. Docs, patches link. We have a IRC channel, libcamera on Freenode, and we welcome inputs from anyone working with cameras. I think that's all from me, and I guess I can take questions now.
Hi, thank you for your talk. We have few questions for you. You can check those at the shared note section here in the big blue button.
Yeah, I see the questions. Will it be possible to use IPO cameras from V4L2 then? Yes, I think so. It can be used, but uh, I V4L2 you will also have to tackle the media controller API from the kernel itself, and is it to be done with fallback devices? I'm not sure I understand what you mean by fallback devices. Does it interact with tools like GStreamer? Yes, we have element GStreamer element, and I think there's good support because it was written by GStreamer developers. So, and Pipewire, I think there is some work in progress going on regarding Pipewire. So basically, as far as I know, Pipewire likes to ask the system resources upfront. But lib camera, what it does, it allocate resources on the fly. So there is like some bit of mismatch that we don't have like a robust support as of now. But I think there was a discussion on the mailing list as far as I know. So it's still, I think some people will bash their heads on it as well. Will Chromium Firefox support this? I hope so. Chromium, we are working with Chromium developers for Chromium OS. So that's the first path to make it work there. And I hope if you have like in the Chromium OS, there's like it goes into as a shared library. So if you just replace it with what Chromium OS ships, the browser, the native camera app will start using the lib camera. So yeah, I'm not sure of Firefox as I have not been actively engaged in Firefox development.
It looks like that's all the questions we have. I'd like to thank you very much for your talk, and I hope everyone enjoyed it. We'll be back in just a few minutes for our next talk.
Thank you very much, and thanks for the questions.
Hello, Musab, can you hear me? I'm checking with our next speaker since he had some issues. Okay, perfect. Thank you.
Can you hear me?
Yes, we can.
Seeing me?
Are you uploading the presentation? Do you have any difficulties with that?
No, but now I'm trying for camera. لسه يا سيف لسه ما بدأ. طيب انا جت الباب. سيف سامحتي. You see me now?
No, we cannot see you, unfortunately. Oh, wait, sorry.
Now?
I think it's loading. Yes, perfect.
Okay, thank you. I will upload the presentation now, right now.
So, hello, we're back again. Our next presenter for today is Mossab. Mossab will talk about RTL experience in Linux. Take it away.
Good morning, everyone. I am here to talking to you about RTL experience in Linux.
Hello, we're back again. Our next presenter for today is Mossab. Mossab will talk about RTL experience in Linux. Take it away.
Yes, you hearing me? Good morning, everyone. I am here to talk to you about RTL experience in Linux. Okay, are you hearing me?
Hi, yes, we can hear you, but if you have any other tabs with sound open, can you please close them?
Okay. Today we will talking about the right to left experience in Linux. Right to left is not just a UI or something like that. It's just a way to think, a way to use, a way to design. It's not just like a mirror, as we will see it after some time. In Linux, the big issue is a way of designing and programming the UI components done by, in general, by LTR designer. So they use as LTR, and they think it's good. But these issues, we live with it as an Arabic user of Linux. So I will talk about this in this summit, and I hope the message will reach to you, all of you. Okay. We will talk about many things in this session. We will talk about the importance of RTL and the directing and shaping, also in some other components, the main components, or especially in KDE and GNOME. Okay, about me, I am Musab Al-Zabi. I am software engineer from University of Prince Migran from Medina in Saudi Arabia. Also, I studied cybersecurity as a minor. I developed in Fedora since 2013 till now, and I am at the top of 1% of the Fedora pages ranking. Also, I maintain Ojuba OS and Linux Arab community. Okay, we will start for the importance of RTL. RTL languages in main, it's Arabic and Urdu, Persian, and Hebrew. The importance of RTL, especially if it's located in about a quarter of the world talking in RTL or needed RTL. They needed it as a Muslims. They need to read in Arabic or use RTL, and also, as I said, the Arabic and Urdu and Persian and Hebrew needed it. So when we use in RTL session, we use it as as of, from the right to left. So, if you see the map, you can see the importance of RTL in programming and using. Okay. Now we're talking about Arabic language in reading and writing. First of all, the direction. Direction, as we're talking about, it's from right to left. But in Arabic languages or right to left languages in general, every letter doesn't have the same shape in the word. So when we start, it's take a shape. In the middle, also it's take a shape. In the final, also take another shape. So the shaping of RTL languages takes more complicated than Latin words or left or right languages, because we need a lot of work here. The work started by FreeBD and HarfBuzz libraries, and continue now with LibRaqam. LibRaqam is I think is the most mature library in shaping Arabic and other right to left languages. As you see here, we can see letter Qaf. Letter Qaf in first. It's right. It's wrote as a single. I can't pointer here. Okay. Here, as you see, the first letter, Qaf, is as isolated. Let's take this as isolated. Take this shape. Also, at initial of the word, let's take this shape, and the medial and the final, as you see. So the very wrong issue and the very wrong thinking way, and when we designing RTL, it's not just like a mirror. RTL more than a mirror. It's a way of thinking. So not get the bottom from on right, not get the tree on right, not get the controller on right or components on right in general, but we need to think as RTL. So when we put the button on right, it should be as readable from right, not only mirrored. It's a common issue we found in later time. We found in Berg's time. So this point I put it as a single point, a single slide, because it's so important. Okay, now we start with the terminal issues. Terminal issues is very common with RTL users. We have a GNOME terminal and console terminal. GNOME for GNOME terminal in GNOME and console in KDE. as a GUI terminals. In the console is better than GNOME in this issue. So in console, it's write Arabic perfectly, but a little issues in positions. But in GNOME terminal, the situation is more complicated. It's just recently you implemented in the newer version of GNOME. They implemented, and it still has a lot of problems. But also the main issue, it's an old bug, and it's continuous with a lot of generations of Linux. Also, the main terminal is a good example of failure in RTL shaping. And as you see now, this is the main terminal. It can't shape and can't write directed, and nothing done well in this terminal. I will show you in the break time, inshallah, a practice of this. So terminal is need a lot of work for RTL sessions. Okay, in the desktop, in general, GNOME designers is very more better than KDE. In GNOME, especially if in the latest GNOME at 3.24, 3.26, also till now, the RTL is good. But in KDE, it's a very worse. In KDE, the main problem is older KDE is better than a newer KDE in these issues, as we will see inshallah in practice time. But I mean, see in this picture, the combination of minimized as an example. It's don't shown in Arabic session. Also, a lot of things has a wrong positions in KDE sessions. As you can see here. And the next slide, which is loading now. Okay, now this is the system settings in KDE. We have a main tree and we have a child tree. As we see, the child tree wrong located here. Also, the sound controllers filled reversely. So when it's shown as 100% filled, when it's zero, it's very disappointing issue. Also, the newer at latest KDE, about 2 version or 3 version from now, we have a lag when we start typing RTL, when we start writing in Arabic or in Hebrew or in any other RTL languages, we have lag. Look, when we open a text editor and start writing, you should wait for loading. What's loading? It's a very big issue here. We can't typing after we have to wait about 4 or 5 seconds for just start typing. It's very big, very disappointing. So the UI and KDE need to be, to redesign for RTL components or for RTL to solve RTL issues. Okay, now we have Dolphin. Dolphin is the main browser for the main file explorer in KDE. Here, as we see, Dolphin success in shown the menu. Also, success in to show the buttons on the toolbar. But in the main button, the main tree should be located right. The main folders and the main window for folders and files should be start from the right, not from the left. As in the Nautilus, this issue isn't found. The Nautilus is good in this problem. We can't find this problem in Nautilus or in okay, from a long time ago, Nautilus good in this way. Okay. As we see here, it's not just only mirroring. It's just to think RTL. So the terminal should be from the from LTR, not a problem. No problem for that. We don't need to mirror everything. We just need to think as RTL. Okay, now we should talk about video controller. The video controller in common start from left to right with LTR sessions, but in the RTL sessions should start from the right. So we have three conditions to make it good. First condition, it should start from the right. The second condition, the left arrow on the keyboard should move the video forward, whereas the right button will take us perversely. Also, the third condition, the mouse controller should be reversed. So when I push at the end of the bar, but from the right, should taking me to the end of the video. This is a common issue in the video controller. So we, as a Linux state now, we in the Venom users they use Totem. Totem is good and do the first and second conditions, but the third is not applied in the Totem program. But we have a lot of issues also on Dragon. Dragon solve the first condition and do the first condition, but the second and third is not solved in it. When we look at the other applications, the common applications like VLC, SM player, they are good. Just in they are not good in any condition of it. They start from right to left, but the second two conditions, it's good of it. So it's built right on wrong base. So they start from right and continue as that. So mouse and keyboard controller is good in VLC, assembler, Firefox, etc. But it's wrong way. From the start, it's wrong way. At YouTube also, when we use it as a web application, it's also wrong. It's start from right to left, and all of this we will discuss in practice and break time. Okay, this is an important thing. The text context. Arabic has two numbers families. We have an Eastern number, Eastern Arabic numbers and Western Arabic numbers. Eastern Arabic numbers, which called in some systems Indian numbers. These numbers in Eastern Arabic world, like Saudi Arabia, like United Arab Emirates, or Syria, or an Eastern Arab world, they use the Eastern Arabic. They use which called Indian numbers. So in this, when we use LibreOffice and you use the context should use the same as a text. It's good in it, and Dr. Khalid Husni had this. I remember when he worked about complex writing. This should be these features should be in general, not only in LibreOffice. Should be in general for the whole system. The user should when he use Saudi Arabia as an example, then the numbers should be as an Eastern. But when he use Algeria or Morocco, Western Arabic, so the numbers should be as Western. But the value, this is the issue. The value of character shouldn't be touched. The value, it should be the number itself. When we write in IBUS or something, typing method, they entered the Western numbers with another codes, not the numbers value. So it's so important to get to fix text context in the next releases of GNOME or KDE. It will be a good, and the options should be opened as in Windows. It's opened for changing to make it Eastern or Western, or same the text context. Okay, now other apps, as we see another examples, we have here FileZilla. FileZilla totally crashed. No, as we see, I think it's a GTK issue. We see here a folder reviews and nothing shown. We have here a text and nothing shown. Also on Java, when we see the upper window, this is a Java application. As we see, it's shaped well, but directed fail in direction. In Wine, it's a very long history with Wine and RTL. As we see here, the crashing with exploring. You see here the folders duplicated or 3 times copying. It's crashed, not correct. It's not correct. Okay, now we will talk about La issue. The button B in the keyboard in Arabic should give La. لا isn't a one word, isn't a one letter. It's two letters. Letter L, lam in Arabic lam, and alif, lam alif. So it's two letter, not one letter. But the X input or them or it can't handle two letters with one key. So GNOME and KDE, when we enter, when we press it B in Arabic, it will shape an a la as one letter. It's a wrong way. It's not one letter. It's two letters. We use IBus as a workaround, but it's not good solution for the all. It's because it's not default or something like that. So it's a very old issue and very old reported issue, but doesn't solve till now. Okay, when we see Microsoft Visual Studio, Microsoft Visual Studio, they have right to left argument. So it's good for the developer and for the designer to. It's good for the designer to use when he build a multilingual application. It's good to him to use this way. So it's a pros for Visual Studio. But in Qt Designer, as example, we don't have this. When we use RTL, they apply the RTL way on it. Finally, I try to make a message to you that don't push any updates without RTL test, because we have previous versions of KDE better than latest. So don't push any updates without RTL test. This is what I can say to you at the end of this session. Thank you for hearing me, and I'm ready for accepting any questions.
Great. It looks like in the shared notes we have a question. I can read it for you.
Okay.
Have you considered writing any open QA test for Fedora or open source for some of the layout UI for GNOME and KDE? Or are you familiar with any RTL tests for the issues commonly experienced?
If I understand you, yes, I'm familiar with the Qt and GNOME, both KDE and GNOME, and familiar with these issues. And I living with it since 2007. Okay, I see questions in chat box. Okay, it's Sayyid Mustafa. What about Bedi? Many times the text placeholder can contain regardless of general. The best way to handle BD, yes, it solve it, but it should be general, not just at the time when we use BD. It should be as a user experience. It should be used every time. Okay. About David, yes, the reverse in Arabic Sign should be enabled, so it's the same issue. Also about Wayland, if it use iBus, yes, it will fix the issue only. But same for other issues, they are the same for Wayland or X desktop. Marco, I have this for the arrow keys. I have this issue, which issues every day. So now I reprogrammed to use it from left to right, but that's wrong, not good. Okay. I will show, but Marco, can you put links for the fixes, please? Yes, inshallah, Volker. In the break, I will show to you all issues that I mentioned here. Sayed, no, video players shouldn't remain left to right. It's a wrong way, not the right way. Or even it's publicly used. Okay. Anyone have?
Like there are some questions added to the shared notes on the left-hand side. Have you seen those?
No, but
Great. Okay. I can read the next one out for you. We still have some time for more questions. The second question is, what about BD? How many times the text placeholder can retain RTL and LTR regardless of the general settings of the app? What is the best way to handle this?
Yes, the best way to handle this is read every part of the text as its properties. So when I start writing from the in Arabic, so the line should start from the right. But when I change the language to English, the line should still in the right, not the context should be from the right to left, not from left to right. The main problems when we use some special characters like when we use the question marks or the something like breakouts or the special characters, especially when the al-aqwas in Arabic, but I missed the word in English. I will write it. Okay, now I will explain this text. Mus'ab. Now when I open brackets like this, and when I change the language, it will be reversed. This is wrong. It should continue as we start. So as Sayyid Mustafa said, the mixing Arabic with English, seeing issue.
Are you ready for the next question?
Yes.
Okay. When in an RTL app, there is Arabic and Latin text mixed, should the Latin text be laid out to the left or right in general?
No, the Latin text should be from the right to left, but the starting the started word is will decide the direction. So when we start for an Arabic word, we will continue from right. But when we write in English, the right will going from left to right, but the context as a whole from right to left.
Okay, thank you. The next question is, will it work better with Wayland than Xorg?
Yes, if we use iBus, I answered for this questions. When we use iBus in Wayland, it's good in writing. It's better than Xmbot. But in the UI or the GUI in general, it's the same. Not there is no differentiation between them.
Okay, the next question is, what about some text fields which should contain Latin numbers? Some apps add Persian numbers if app language is set to Persian. This made issue for my calendar timing.
Yes, I think it should be optional from the system settings. The options should be the Arabic Eastern numbers and Arabic Western numbers. So, or going with the context.
Great. Okay, our last question before we run out of time is, you said video controller should be reversed. Material design guideline says don't reverse. The logic is that it represents the physical device.
Yes, so I create a whole slide to think as RTL. When we use RTL, we need to think as RTL. In video, yes, from YouTube about 2006 till now, yes, I am personally programmed to use it from left to right, but it's wrong. In Totem or in Dragon players, it's right to left, and this is good. Even they have some issues, but in general, it's good to start from right to left, not from left to right.
Great. Thank you so much. It looks like that is all the time we have. I hope you enjoyed giving your presentation as much as everyone seemed to enjoy listening to you today.
Thank you, and I'm waiting you in the break time, inshallah.
Wonderful. Thank you so much.
You're welcome. And thank you for hearing me.
Can you please mute and turn off your camera?
Yes. Salam alaikum.
unmuted.
Hello.
Hello.
Hello and welcome back, everybody. I'd like to introduce David Edmondson and Benjamin Berg, who will be talking about next generation application management.
Thank you very much for the introduction. Alison, could you put a slide back on? As I don't know how to do it. Brilliant. Thank you very much. Oh, I have become a presenter. Brilliant. Thank you ever so much. Okay, so the title of our talk, Next Generation Application Management, subtitle, System D for the Win. And you might have seen similar talks presented at Academy and Guadec, but now we're presenting them together. So we're joined by me, David Edmondson, from the KDE side, and Benjamin Berg.
From the GNOME side, yeah.
Yeah, so I work for Blue Systems, Ben's working for Red Hat. So opposing desktops opposing colors, a probability to have an EU flag in the background. We've got a lot of oppositions, but we also have the same problems. So as a desktop, what we want to do is get a user able to control their system. It's our job as a desktop environment to put a user to your application so they can run your applications, use your applications, and most importantly, manage your applications. So in terms of managing what's going on your own system, it used to be a case several years ago, you'd have your browser, you'd have your instant messenger, and you'd run PS and you would see your browser and you would see your instant messenger. And that would be pretty straightforward. And when I started using Linux 10 years ago as an idiot, I could understand it. Now, the situation is very different. I run my browser, my instant messaging client, and this list is truncated because it doesn't all fit on one slide. It's ridiculous. And even as I've grown as a Linux user, I now no longer know what's going on my own system. So my instant messaging client here, Discord, is 13 processes. And they all have ridiculous names that don't make any sense to anyone. Even if you had like a PhD, you still wouldn't know what any of this is. So understanding what's going on is difficult, just to see everything, but it also means that any aggregated resources are effectively meaningless. If I look at in our PowerTop and see which process is draining the CPU, oh, it's not Chromium, it's a web renderer, like a sneaky disguise for Chromium, so we can't see what it is. And the problem is it does fool people. You can't be in control of your own system anymore, and these stats are effectively meaningless. The other problem we have, I mentioned previously, our instant messaging client was 13 different processes, whereas Krita, just one process. So you've got this intense graphical application, and all the scheduler is going to see is 14 processes. So if it's 14 processes, the scheduler, trying to be fair, is going to give each of them as much resources as they ask for evenly. But evenly, without the context of any metadata, is in this case wrong. And there's also a situation of being fair between users, particularly if you're in an enterprise setting, kind of multi-seat environment where you have one physical machine and there's several users attached. It doesn't make sense that one person's browser experience gets hampered because somebody else is running some intense MATLAB operation sucking all your CPU away. It should be fair that each user gets the same amount if they both try and request all of it. Or a similar situation, your desktop's locking up, you know something's going wrong, you SSH in to try and fix it. Your SSH terminal is hanging because all your CPU is sucked up by a thing you're trying to fix. That's not, there's no concept of fairness with a new session that started. It should have as much resources as this session that's running if it tries to get them. And as well as being fair, it's difficult to try and discriminate things to be unfair, go the other way. So currently, we've got background services hanging in the background, like the file indexers or backup solutions, and you can run nice, you can kind of suppress them down to an extent, but only if that application itself has really opted in to do it, or you go out and manually figuring all of the extra steps by hand, which doesn't really work. But it's impossible to elevate a process. And we generally, especially now with the compositors and Wayland, we want to keep the desktop responsive. It's super important to keep your mouse moving smoothly and everything, even if something else is happening on your system. So we want to boost that. But because NICE is system-wide, you can only drop niceness. You can't raise it without additional permissions. Because everything is relative to your whole system at once, and you need to have elevated permissions, which means it's not usable for us as a desktop. So we need a solution.
And the solution is to use cgroups, which is the kernel level feature, to group processes together with systemd to configure all this stuff. So cgroups allows us to hierarchically order processes and allows us to put them into groups, control groups. That's where the name comes from, cgroup. And then we can all nicely hierarchy them, and we know what's going on, and we can actually figure out how to configure it, and we can configure it. So we have lots of controls available. Like the most important for us are CPU, I/O, and memory, but you could also imagine like a graphics memory controller later on, which doesn't exist yet, which would be very interesting to have. And then we have systemd, which hides the details and configures it for us. So if you look at like a hierarchy, this is the hierarchy from a running GNOME session, basically. So what we have is that the system, on the system level, things are split up as like user slice, that's all the user processes in there, then user 1000 slice, that's the process of my user, and user 1000 service is the actually systemd service that manages all my processes. And then underneath there, the session slice contains the important session processes, and app slice will contain the applications. In this case, it's a terminal with a few sub-processes and everything. So you notice, for example, that GNOME Shell Wayland service is actually GNOME Shell. It's X Wayland, and then it's also IBIS, like input method stuff, all grouped together in one group. And then the C group controllers allows us to get more information and to set things up. So the CPU controller is for CPU resources, and it'll, for example, give you statistics for each C group. It'll give you pressure information, pressure stall information. That means that the process is not actually doing anything because it's waiting for this resource to become available. So if you have 16 processes running and for cores only, then each one will only run 25% of the time at maximum, basically. And you'll see that here that the processes are waiting. And CPU wait allows you to configure the wait and prioritize parts of the process. These processes configure to other, or there's CPU max, configuring maximum, and a lot more things. If you want to know the details, you can look into the C group v2 documentation in the kernel. Another important controller is I/O. Same thing there. You get the statistics, you get the pressure, you get the weight. You also have like a latency flag, so the kernel tries to guarantee low latencies, but that's actually not non-trivial to use, unfortunately. Also, the I/O controller, while really important to keep the desktop smooth, because quite often when the desktop is hanging, it's waiting on things to be loaded from disk. So it would be very useful to have the I/O controller fully working. Unfortunately, as C groups are primarily developed for the data center and on top of Btrfs right now, to actually use these features, you need to have a Btrfs right on a partition on your disk. You can't have like a Lux volume in between or something like that. But if this works, then you should get very good process separation, process isolation between things. And then you have also the memory controller. Memory is slightly different to others because you have one huge chunk of memory, but you can't fairly, like, one process might use a lot, another process might use little, and things will change over time. So it's a different thing to distribute fairly. But you also get all the same information, like the current memory consumption, the statistics, and the pressure information. How often are you waiting for memory to be swapped in and read back from disk? The interesting part, and something that I would like to point out, is that memory.current, so the current memory consumption of a C group, actually contains all the caches. So file caches are part of what a process needs to run. So if you have like a process that, I don't know, reads a 2 GB file at startup and then does nothing and just sits there, and no other process needs the memory, you will actually see memory current for this process to be above 2 GB of memory, because this memory is being used for the process right now. Even though it's not needed currently, it's still there sitting in case the process needs it again. I'm pointing this out primarily because people are getting confused, because memory is not just the heap, the allocations that you do, but memory is everything from allocations to executables and libraries, and also like shared stuff in between applications. And then some of it will be swapped out, some of it will be read back from disk when needed. So I was going to like show this a little bit, just with the CPU, with the entire screen. So, what's going on now? This worked before. There. There we go. So what I have here is terminal tabs. So GNOME Terminal is already smart enough to place each tab into a C group. So what I'm doing now is I'm running test, which is just stress ng burning CPU. And oops, apparently I had it already enabled. So if I don't do anything, what you'll see is that I have one process running in one tab and two processes running in another tab. So this is tab 1. Test 1 is the first tab, the -2 is the second. And you'll see that all of them get 1/3 of a CPU core. They are all pinned to the same core, so it's 100% overall. So even though they are in different C groups, they are still treated the same way between applications. And now if I enable the CPU controller, so I just enable the CPU controller for the sub-tree of the terminal, what happens is that each tab will receive the same CPU amount. As one tab is running one process, this process will receive 50%, and as the other one is running two processes, each one will get about 25%. And you can see this here very nicely. Test 1 is getting 50%, test 2 is getting 25% of CPU time. And then we could even go further. So if I look at the C group, C group, so I can read the C group information for the process, so I know in which C group it is in, which is the scope. So now what I could do is I could even further prefer the test 1 process, the C group in there. So what I do is I echo 500 to CPU weight. The default is 100, so this will now receive 5 times more CPU time than the test 2 processes together. And you'll see that now it's 80% for test 1 and around 8.3%. Okay, this stopped being weird. So you can see that we can change a lot of things, and this way configure what's going on and actually distribute things in a more fairly manner. Okay, so another thing that I wanted to mention is that Facebook is doing a lot of development for their servers on the C group stuff, and they have now released a demo tool, like to test all the different features and everything, and it'll make sure that your system is configured correctly and to try it. So as they are developing all the kernel features, they also test, obviously, that it's working well, and then they use it to separate the different services running on the same server. And this demo, like, check out the demo if you're really interested. There's a lot of documentation there on how it all works and why it works. So if you're interested, this is a great way to learn more about C groups and how they are working. And then on the systemd side, what we need is it'll manage the C groups for us, and it'll set all the attributes up. So basically what we do is we simply use systemd. And because it makes sense to do it the same way between cross desktop, we actually created a draft specification. It's still a draft. There is probably going to be a few changes, but the major things are scoped out. So the idea is that we split the session into 3 parts, which is the session slice, with all the very important processes that are critical for responsiveness and can't easily be restarted, app slice, which is the bucket where everything else will go in by default, and systemd actually just changed, so it will actually go in there by default. And then you have background slice, where we want all the tasks to go that we can slow down to like crawling halt if in case the rest of the system needs resources. And an important aspect here is that we're using systemd, and what we are doing is encoding the application ID into the systemd unit name. So we can, from the process, grab the C group name, and then from that just extract the application ID, and we know which application something is belonging to, the process.
So in terms of the current state and the rollout we have within the desktops, within GNOME and within Plasma, we're at a situation where every time you launch an application now, it gets put in its own C group. And that's something we've had in Plasma since 5.18. GNOME's had it for a while as well. And then the next step is surfacing this to your users. So right now we're putting things in C groups. Your kernel can make use of this information, and that's already happening on your system right now if you're up to date, and you should always be up to date. But we're not really exposing everything that we can be exposing so far. So in terms of exposing this, one of these classic examples is System Monitor. So in KDE Plasma, we had just a big list, and we could turn it into a tree view, but it's still just a tree view of processes, which loses a bit of information. And this is what we had before, and this is what we're going to see coming up in the future, where we see an application as one thing. We can see aggregated resources, aggregated memory and CPU and disk usage and memory as well. But then we can drill down if we find we want to further. So we took all this information and we can present this in a way that's really easy to consume. GNOME tried then.
Yeah, we tried. So GNOME actually had some heuristics, like looking at the binary name, trying to figure out which application it belongs to, and stuff like that. But that wasn't really quite working. If you look at this screenshot from before, which is like system is like the catch-all, where if it can't tell where it belongs to, it just drops it in there. You see 3.4 gigabytes. And then notice the GNOME web browser is using 560 megabytes here. And then if we look at the next slide, David, thank you. What you will see is that suddenly system is only using the 1.8 gigabytes and web is using 2.1 gigabytes. These are the same processes. I just patched like the unpatched version and the patched version. And so suddenly GNOME is actually able to better tell which memory, what process, what application is using the memory. And all it needs is looking at the PID, figuring out which C group it belongs to, and then extracting the name from that and using that instead.
Yeah, so it's much more reliable because it's sending all your data through your core, and then we can read it from there.
So we're now lying to you differently, but the lies are better.
Yeah. So the next part of this, as well as surfacing this in terms of viewing a stat, we can also control things. So one thing we want to land in Plasma, it's a very universal idea that I'm sure we're going to see in GNOME very soon as well. It is concept of a foreground booster. So typically, if you are stressed for resources and this computer has to make a decision of what to prioritize, your best thing is to prioritize the active application, because that's where the user's looking, that's where they're going to notice any slowdowns or glitches or anything, and it's clearly where they're trying to divert their attention. So it's become an incredibly tiny, simple task. Now we have the C groups. A tiny daemon, it's literally just 50 lines, just watching for what's active window, and when this happens, we just adjust the weights. And as I said, what we can do with C groups compared to what we could do with NICE is we can move things up as well as down. And that allows us to just boost things instead of just suppressing these background services.
So we can do a similar thing on the system level for the users. We already mentioned that we want to do shared between users fairly and stuff like that. So I looked into your resource D, which was also the idea of keeping your desktop responsive. So the idea is that we, first of all, enable all the resource control features, because right now GNOME currently just uses the hierarchy, uses C groups, but doesn't actually enable all the features. But then furthermore, it makes sense to prefer the currently active user who has a graphical session. So if you have a mouse moving around, it should be smooth all the time. And to that end, the idea is that we also give memory guarantees to this user and we boost the important session processes. So what UresourceD, just by simply installing it, effectively does is that all your applications are going to be treated as equals, because it'll just enable the C group controller by setting the appropriate systemd configuration option, just using a drop-in configuration. So if you have like a parallel compile job in one terminal window and then a single browser tab like the videos call here, the video call will still get a lot of CPU time and can basically use a full CPU core for its purpose. And you also get like fork bump protection effectively. And So what we do, what uResource-D does, is a tiny daemon that sits in the background, and all it does is look at which user is currently active on a graphical login, and this user will then receive a share of memory that is guaranteed for it. So it can actually, right now it's like 250 megabytes by default. So 250 megabyte share of memory is passed to the user, and this is then passed to the important session processes. And so if an SSH user comes in and runs their simulation, obviously not using MATLAB, but using NumPy and SciPy, then it will not slow down the rest of the system and the graphical user. So effectively what we can achieve is there's some protection of the session from thrashing, because with user memory guarantees, it will at least have some responsiveness left. And this compositor receives also a greater CPU share, and this way all the important services or everything should stay reasonably responsive in most times. So it's a very simple piece of code, really. It's a small policy daemon and systemd unit configurations. We have rolled it out in Fedora 33 by default now, so you get it there out of the box. And elsewhere, I'm not sure if anyone else has picked it up, but you can also just check it out on GitLab, uResource-D, if you look for it under my username.
Going to be present again. So what does this mean for you as an application developer? We're here at LAS. So most of you, hopefully, are application developers trying to make all your applications work excellently on Linux. So we're here talking from a desktop point of view. And generally, if you're an application developer, you don't need to do anything, because it's an application, it's a desktop itself that when you open an application from the start menu or whatever your GNOME equivalent is, it has a job of putting it in a C group, adding in metadata, tagging everything. So you generally don't need to do anything. But there is a case where applications then launch other applications. So if you open a link in either an application, you're opening a link, or if you're creating your own file browser from scratch because you don't like the ones we provide, then obviously when you click on a file, it's going to open a whole new application. So from your point of view as an application developer, the important part is to use the relevant high-level API that we get from the stacks. So from KDE, that's Open URL job or application launcher job, and this takes care of all of these details under hood. For GNOME, that's G-App Info Launch URIs or this other one, and that will take care of all of the details. If you're running inside a Flatpak, you're going to need to use the relevant portal API anyway, because otherwise nothing's going to work. And if you use a relevant portal API, again, all of this will be taken care of under your hood, and you won't need to worry about it. The dream. But you still have all of the options available, so we can capitalize on everything as a desktop, but you as a service can as well.
Right. So let's just give a few simple examples and some use. So usually, right now, if you have a service that starts at login, you might ship an XDG out to start file, and that's actually still fine to do in general. But if you want to get more control over this, the way to go is to use dbus activation, probably. So the best way, what you can do is you ship a dbus service instead. You activate that dbus service, and then dbus, you can configure it to start a systemd service unit in order to run the dbus service. So at that point, you have a systemd unit file that you can write and that you can provide. So you can simply dump in all the information and you can configure it as much as you like, while getting all the different features that systemd has, that the resource configuration has, and improving your integration into the desktop. So this is like a very good way of being able to leverage the features, just run everything inside a systemd service as much as possible. And then there you can set, like, for example, the systemd slice, the set custom resource limit, or also restrict access to system resources and other things. Like you could prevent your application from running fork, for example. So a simple example might be like a backup application, which should run in the background. It should never slow down other applications that are running on the system. So you want to make the the desktop aware of this background service running. So this is why we want to place it into background slice. And you also want to make sure that it's not hitting the disk too much or preventing other applications from having the files in memory that they need. So the way to do is, as I said before, you just create a dbus service just only for the backup job itself, and you put it into, or you could also put it into transient scope, which is a different way, which is probably more complicated to do, really. And then you configure this service by setting the slice to background slice. So we tell that it's running in the system in the background, so the GNOME, the shell knows what's going on, the desktop. And then what you would also do is set memory high to a relatively low value. And memory high, as I explained earlier, also contains file caches. So that means you effectively encage the process to a pretty small amount of memory on the system, but you also make sure that all the file caches that anything else might need will remain cached, and all the other processes won't be inhibited. And another scenario would be the terminal application, or also like a browser might be a similar kind of thing, where you want each terminal window, each tab to be treated equally. And this is the demonstration that I did, where in GNOME Terminal it's already possible to do by doing a very simple drop-in configuration. So in that case, what you would do is you would spawn your sub-process and you would create a transient scope on systemd. So you tell systemd, all right, this new process is actually its own group, and you move it over. And then by doing this, you can also configure it using a drop-in. So the user can tell systemd to configure it if they wanted to, just by matching on the name, basically. So VTE GNOME Terminal calls it VTE-spawn-something, and then we can configure everything that starts with VTE-spawn- to change its attributes. So an example might be that you put it into slice app-org-my-terminal. So app is the prefix, so we order it hierarchically underneath app.slice. This is how systemd does it. So the dash is actually like the hierarchy. So you get app and then app.slice, and then underneath app-org-my-terminal slice. So we have a hierarchy there, and we are telling the desktop that this is actually belonging to my terminal. And then kill mode in this case would set process, because if you close a tab, you now have the choice. Do you want to kill all the processes that are inside the tab, or do you want to leave the processes running and just kill the main process that you initially started? And this is what we choose here, is that we only kill the main process, because people usually expect things like screen to continue running. And then if you just enable CPU wait and I/O wait to 100, which is the default value, you get the effect that I showed earlier, that the resources are distributed evenly between the tabs.
It's quite a lot of extra content. I can see already seeing the questions, people going, oh, what are the specific things I need to learn? Obviously, there's quite a lot to say, but we can just give you links instead for easy use. So it is a specification. It is a cross-desktop standard that we've been working on, because it is important that we all use the same naming scheme for our slices and our naming scheme for how we refer to different C groups, particularly if we're trying to retrieve information from that. So upstream specification is still a draft, but it's mostly what you should be working against. I've also put a comprehensive list of code examples of how to use this as an application. I mentioned a high-level API earlier, which you're probably going to want to use anyway, but I've also put in low-level examples that work with straight-up C, straight-up glib, even just a bash version as well. Or basically how to approach all the different layers of the stack, and how you can put this. Obviously, this isn't the best place for it, just being on a random gist, but we need to come up with a way of coordinating our documentation. Also, as mentioned, it's something we've both been doing on our different sides. Ben did a talk at Guadec, I did a talk at Academy. Ben also did a talk at Linux Plumbers, talking to kernel people about how actually using the features they did. So if you want to see the same talk again, but with more of a twist towards a specific part, there's some relevant links here. So thanks for listening. If anyone's got any questions, and I can see that people do, we're happy to go through them.
So the first question is, if an application starts another application, it should have its own slice property. I guess this needs additional work by the first application. So yes, this was what we were going into earlier. In the usual case, you just use the high-level APIs, and the desktop will do the right thing for you. With glib and GNOME right now, the patches are currently still pending review, but it's going to happen. So if you use the high-level application APIs to launch application or to launch URLs, the right thing will happen. If you use the low-level APIs to launch something, a larger process that you want to encapsulate, then you'll need to do extra work and you'll need to do some stuff yourself. But one of the tricks to work around this is you use dbus activation for this part. So that's a good way of avoiding having to deal with the low-level stuff.
And the second question, what do we need to take into account as application developers? Basically the same thing again. You want to be using high-level APIs anyway because there's important details like startup IDs for window management purposes that it's best to use regardless. Is there a timeline for this being enabled in GNOME and KDE? As I mentioned before, in terms of actually applying the C groups, we both have this enabled already. And it's, from our side, on the KDE side, it's just idea of do a silent rollout that won't break anything. It just tags things, and we've left it all the way the same. So it'll be some subtle changes to resource management at a kernel level, but it's nothing that should break a user experience. And it will just sort of slowly keep adding in different parts on top as we can make more reliance on fixing these tiny edge cases from the fact that not everything is being spawned correctly with the part above.
So exactly. So like, for example, in GNOME right now, the file browser, because the glib APIs aren't merged yet, the file browser will actually not. If you launch a PDF viewer in using Nautilus in GNOME, then it will be accounted to Nautilus right now. So these kind of things makes it not suboptimal to enable all the features. Right now, we actually sometimes it's enabled, like on Fedora 33, it will be enabled for GNOME. For KDE, not yet, because the systemd work is not there yet in Fedora. But on other distributions, it will not be enabled. And also, there's a lot of ongoing development with regard to OOM killing and other parts of the resource control problem. So you'll see a lot of changes coming up in the next 1 or 2 years, I would say.
Yeah, but I don't think it's going to be a definitive, it's on or it's off. It'll be a gradual, we're going to rely on this for this feature, or it's going to be a fallback heuristic for this, or it's going to be used here. And we'll just see these tiny little parts come over time.
There might also be changes for application developers with like systemd, OOMd, where you can say, if my application is waiting a lot for I/O, please kill it.
Yeah. In terms of phone devices, the resources are even more strained there, so this absolutely applies. Basically, it's almost more important. Another thing that C groups provide, which we've not mentioned yet, is another controller called the freezer controller, which allows you to just stop an entire application at once. And compared with SigStop, it fixes a couple of bugs that you just can't. The application is unable to prevent being frozen. The control group can just freeze it. So it's not something we can use right now, but it's something that in the future could be really, really cool and really useful for your phone. Yeah,
or like completely suspending background tasks while a game is running or something like that, which also makes sense.
As for your comment about existing launchers, as a general point, yes, existing launchers will need to be changed. On the specific point of Steam, we've been speaking to Steam people. I can say they were one of the people that pushed towards this because having a high frame rate of a focused application, if that's a game, is something they care about. And they've actually reached out ahead of time to say this is a goal that we want. And it's something that they're going to be adding at all completely. And in terms of how can we help make this possible, one of the important points is if you run systemd-cgls, which is equivalent like of PS, but shows our hierarchy. Thank you, whoever put that in the notes. And you can see slices, and you can see the hierarchy building up. And just run that, look for anything that seems out of place, and report it, fix it.
Yeah, that would be a good thing. Then the other thing is that, for example, systemd is getting systemd OMD right now, and the idea generally would be that rather than that we start using that to kill processes, so the kernel OM killer will only kill processes when the system is already frozen, basically. And then in Fedora, we are using early OM now, which kills processes when, let's say, when there's not enough memory available for caches anymore. But the general idea would be that with systemd OMD, what we do is we kill processes when we actually are hitting the disk too much and the system is grinding to a halt. So if some people are interested, it would be really cool if they could grab the latest systemd, which contains systemd OMD, and start playing with the different settings and start coming up with scenarios on how to test whether the desktop is remaining responsive under load.
And one other thing, if you really want to help, one part we've got in Plasma at the moment is using systemd to manage all of our background and whatnot, which is somewhat separate from the concept of managing applications. And right now, this is off by default on Plasma, but hidden behind a config option that you can turn on. And I have a blog post that says where that config option is. If you Google for it, I'm sure it will come up. Or just reach out and ping me if you want to enable it and have any questions. I think we're probably out of time.
Yeah.
Actually, we technically have 5 more minutes. If there are more questions, please answer them.
No, I'm not in a rush anyway.
Yeah, that's fine.
Like one's coming in right now.
Okay, Ben, you should read it out in real time as it comes in.
You mentioned the debug starting for getting into management. Is that only required when you... Okay. Is that only required when you provide arguments or also for background processes that use config files? Not sure what config files means here. So
I assume if you have your own specific...
Sorry. Yeah, you finished. Okay. So by default, dbus will already start each application. If you use dbus activation or something like that, then it will start everything in a C group already. So you get all the features or arguments. I'm not quite sure what. It makes sense when you actually have something that should be an entity of its own. And starting using dbus is just one method of placing the process into its own C group, and also being able to ship systemd configuration files so that you can configure it more. So you get both out of this, right? At the first step, if you just use dbus activation, it's one method of starting a process. So it will end up in a systemd unit. And then as the second step, you can provide a your own systemd service file to provide your own configuration options.
I've placed that paste bin of all the different implementations and all the different ways you can launch C groups into your shared notes chats, because it's easy to click on a presentation. And that mentions dbus, but also mentions all the other different possible ways you can spawn things in managed C group ways.
Okay, well, now it looks like that is all the questions wrapped up. A very, very big thank you to both of you. It was a great presentation, and I hope you are sticking around for the rest of the conference. We will be taking a short break for the European afternoon and the American morning and the rest of the world's evening. And we will see everyone back here in a few hours.
All right, thank you.
Thank you very much. I'd also like to mention that we are hosting breakout sessions during the break. There will be two, one starting at 1:10 p.m. UTC, the other at 2:15 p.m. UTC. You can find more information on those on the schedule, and they will both be hosted in this same room.